Good morning, 7th grade. This is going to be our last lesson for chapter 1. So we're looking at electricity from magnetism. First, let's read about an MRI technologist. Does working in the medical field interest you? Are you good at operating devices? Do you have a knack for soothing anxious people? If you answered yes, you should think about becoming a magnetic resonance imaging technologist, or MRI. When a patient is put into an MRI machine, radio waves and magnetic fields are used to create images of the patient's internal structures. The doctors use these detailed pictures to determine what is wrong with the patient. The MRI technologist's responsibilities include operating the MRI machine, comforting nervous patients, and maintaining patient confidentiality. You can become an MRI technologist by completing a bachelor's degree program, an associate's degree program, or a certificate program. So, if that interests you, maybe you want to become an MRI tech. So, let's look at our key questions for lesson 5. How can an electric current be produced in a conductor? How does a generator work? And what does a transformer do? So, looking at a few different machines here. So an electric motor uses electrical energy to produce motion. I'm trying to move my bubble here. And it just doesn't want to move. We're going to go right there. Okay. Scientists in 1831 discovered that moving a wire in a magnetic field can cause an electric current. This is what allows electrical energy to be supplied to homes, schools, businesses, or other buildings around the world. A magnet can make or induce current in a conductor, such as a wire, as long as there is motion. So we're moving that wire, which causes electric current, and that allows all of us to be supplied electricity. An electric current is induced in a conductor when the conductor moves through a magnetic field. So, electromagnetic induction. Generating electric current from the motion of a conductor through a magnetic field. Current generated in this way is called induced current. If the coil and magnet do not move, the galvanometer's pointer does not move. When either the wire, coil, or magnet moves, the galvanometer registers a current. So let's look at this picture over here. So the first one, the coil is moving up, and then the pointer moves clockwise. If the coil moves down, the pointer moves counterclockwise. The magnet moves up, it moves clockwise, and the magnet moves down and it moves counterclockwise. So as long as one of them moves, the galvanometer registers a current. Direct current, or DC, is a current with charges that flow in one direction. Battery produces one when placed in a circuit, and charges flow in one direction, from one end of the battery to the other end. Excuse me. If a wire in a magnetic field changes direction rapidly, the induced current also keeps changing direction. Alternating current, or AC, is a constantly reversing current. Alternating has major advantage over direct because it can be easily raised or lowered. What's a generator? A generator is an electric device that transforms mechanical energy into electric energy. And a generator uses motion in a magnetic field to produce current. So an electric company uses giant generators to produce most of the electrical energy you use each day. And then huge turbines turn the armatures of the generators, and they spin when there's water, steam, or hot gas flowing through them. So there's 4 parts to a generator. Move my bubble again here. There's a slip ring, which you can see here, right, this circle, and that turns with the armature, allowing current to flow into the brushes, which are over here, these little things. The crank, right here, turning crank rotates the armature, is over here. The armature, this reddish-orange thing, is a rotating armature. One side moves up, the other side moves down. And then the brush, which was those little copper gold looking things, are when connected to a circuit can be used as an energy source. What about transformers? I'll have to move my bubble probably again. Transformers change the voltage so you can use electricity. Homes use a lot smaller electricity than the generator produces, so the transformers change that voltage so you can safely use it. A transformer is a device that increases or decreases voltage. It consists of two separate coils of insulated wire wrapped around an iron core. A primary coil is connected to a circuit with a voltage source in alternating current. A secondary coil is connected to a separate circuit that does not contain a voltage source. So the change in voltage from the primary coil to the secondary depends on the number of loops in each coil. Let's look at our vocabulary words from this lesson. Electromagnetic induction is generating an electric current from the motion of a conductor through a magnetic field. Direct current is current with charges that flow in one direction. Alternating current is constantly reversing current. A generator is an electric device that transforms mechanical energy into electrical energy. A transformer consists of two separate coils of insulated wire wrapped around an iron core. And that is it for lesson 5. So there's an assignment on Edmodo for you, some questions to answer. That is due on Thursday, and then on Thursday you're actually going to have a review and then a test for chapter 1. As always, any questions, let me know.